Kia ora. What do you need to know for the 91166 exam? So there are two aspects for chemical reactivity. It's the rates of reactions and equilibrium principles. Now, for rates of reactions, you've got four factors you need to be able to explain. And in your explanation, you must be able to use collision theory, including the activation energy. So you need to think of what is happening to the particles. So the first factor is concentration. Now, the key idea here is the number of particles in a particular volume. So don't just say more particles or the particles are closer together. So what I'm trying to show here in these blocks, the left-hand block has got 10 particles, the middle block also has 10 particles. Yes, they are closer together in the left block, but it is not a greater concentration because they are still 10 blocks per unit volume. The block on the right has more particles per unit volume because it has 18 particles in the same volume as the others. So always state, yes, there are more particles, they are closer together, but it's more particles per unit volume. The second idea is you need to compare the frequency. Don't just say more collisions. If I have road A with 5 collisions and road B with 2 collisions, you could say road A is more dangerous. However, if I say road A has 5 collisions per year, whereas road B has 2 collisions per week, then road B is more dangerous. So always relate the collisions to the unit time, or say more frequent collisions. The second effect is temperature. Now, temperature increases the kinetic energy. If you increase the temperature, you increase the kinetic energy of the particles, so the particles move faster. And this gives a twofold effect. First of all, there will be more frequent collisions. If you're walking around a room or if you're running around a room, you're going to collide more often if you're running. However, the greater effect is actually that when you're running around, yes, there'll be more collisions, but you're going to be colliding harder. It'll involve more energy. And that means that a greater proportion of the collisions will exceed the activation energy. So we can have a collision, but if there's not much energy involved, it won't make any change. Whereas if there is lots of energy involved, it'll exceed the activation energy, and therefore you can form a product, there will be a change. So the key idea here is more frequent, but even more important, that a greater proportion of the collisions will exceed that activation energy needed. Surface area, it's really that if I've got a greater surface area, there are more particles now exposed to react with the whatever it is in solution. So always think of, are you talking about solid, liquid, or gas? So your explanation is clear. So if I break my solid into smaller pieces, then I've got more particles of the solid available to react with the particles in the solution. And so there will be more frequent collisions. Finally, the catalyst. The key idea here is the catalyst provides an alternate pathway. So if you think of a mountain going to the products, I don't remove the mountain. The mountain is still there, so any energetic particles when they collide and they exceed the activation energy, can still react to form the products. But I now have another pathway that needs a lower activation energy. And therefore, I don't actually increase the number of collisions. I have the same amount of collisions, but a greater proportion of those collisions will exceed the activation energy. So here, if I go the old pathway and have a certain amount of energy in the collision, I don't affect the change because it's not enough energy. But under the new pathway, that would be enough to change and form the products. So that's rates of reactions. The other aspect was equilibrium principles. So the ideas here is looking at it on the macroscopic level. In other words, what you see, and you won't see any change. So if something is equilibrium, you don't see anything. You don't see a change in color. You don't see a change in volume or anything like that. But on a microscopic level or on a particle level, there's a constant change of particles going, say, into vapor or to the products and back to the reactants again. And that's the dynamic nature. The factors affecting equilibrium, you've again got 4 factors. They are very similar to the factors affecting rate, so don't get confused. And again, if you're asked a question which doesn't clearly specify equilibrium or rates, you can talk about, say, temperature affecting the reaction in terms of rate as well as in terms of equilibrium. Don't just pigeonhole in one or the other. Always think of both and then check the question and see, are they referring to rate? Are they referring to equilibrium, or haven't they said and they actually want both? Catalyst is a bit of a trick because, of course, a catalyst has no effect on the equilibrium system. Temperature is the only one that affects the equilibrium constant value. All the others do not affect the actual value. You need to learn Le Chatelier's principles definition and know how to apply it. Which way does the equilibrium position shift towards the products or the reactants if I increase the temperature for, say, an endothermic or exothermic reaction, or if I increase the concentration or increase the pressure. And particularly then there you have to count the number of particles under the reactants and under the products to see which way the equilibrium position will shift. Then the significance of the equilibrium constant, is it large? So will it form lie towards the right in terms of the equilibrium position, or if K is small, that means I've got much more reactants. Then homogeneous just simply means in the same phase. So we'll never mix a solid and a gas in a given equation. You will be asked for calculations. Now you could be given asked Q, which means the system is not in equilibrium, K, the system is in equilibrium, or the concentration. And this means you must be able to write the equilibrium constant expression, because you can't do the calculation unless you can write the expression. So make sure you practice and know how to do that. You could have some squares and cubed values in your expression, so know how to use those in your calculator. Because if you can't use cubed or cubed root, then you're not going to get the right answer. Also show full working in your calculations. If you ask for concentration, make sure you have a unit. If you ask for K or Q, there are no units. And always check the number of significant figures, that is correct for excellence. Then finally, you need to be able to define acids and bases in terms of your proton transfer. So learn the definitions of a strong acid, strong base, weak acid, weak base, but acid with its conjugate base, and so on. Make sure you know all those terms and you can define them. Then explain the properties of weak and strong acids in terms of conductivity, rate, and pH. So it's a good idea to be able to recognize what a strong acid, so learn them off by heart, your nitric acid, your hydrochloric acid, your HI, HBr, perchloric. That's more than what you sort of need to know, but if you know those 5, you're also well set for level 3. Also learn your ions, so you know where to break a substance into its ions, and you will know its charge. So if I say sulfuric acid, you'll know it's H2SO4, which means the anion will be SO4 2-, and you won't be thinking of is it SO4 1-, because of course if you remove one proton from H2SO4, then you'll land up with H+ as well as HSO4-. And if you then remove another proton, then HSO4- breaks up into H+ and SO4 2-. So learn your ions. Also, you will be given calculations. Now, you are given a resource booklet with these 2 calculation or formulae in it, so you can refer to the resource booklet if you're not sure or you think you've forgotten it. You can be asked to calculate hydronium ion, hydroxide ion, or pH. So make sure you've practiced those calculations. And in pH, give your answer to 2 decimal places. We don't follow the significant figures rule here because pH has a slightly different way of working out significant figures. So all the best. Kia ora.